Hello and welcome back to the second of this three-part video. Today, we're going to continue looking at probability. Now, if you haven't already, please subscribe and please go to the answerme.com website where you can vote for next week's topic of videos. Now, on to this question. So at the end of the last video, I asked you to solve these two questions by yourself. If you did, great, well done. You can even move on to the third part of this question, the third video, where I'm looking at expected probability. If you want to confirm your answer or confirm your method, or you want to understand how to do this, stay along. So, first thing we need to do is we need to find no greens. So what does this mean? So no greens is very hard to calculate. Well, to calculate for no greens by itself would be quite a difficult challenge because we'd have to go and calculate the probability of not getting this and the probability of not getting this green here. But there is a much simpler calculation that we can do, and I alluded to this at the end of my last video, and that is we can use this branch here, the probability of getting two reds, to help us understand the probability of getting no greens. Why is this? Well, getting two reds, if we pick two lollies, means we don't pick any greens at all. And so this branch here of two reds is the only branch of all of these. So this, and this branch, it's the only one that doesn't have any greens in it. And so this red branch here is the same as writing no greens. So we calculated how to find two greens on our last video. So it's the multiplication of the first probability multiplied by the probability of the second. Now, we can do the same thing with this two red situation. The probability of our first red is 5 on 8, and the probability of our second red is 4 on 7. If you want to understand why these probabilities are the case, please go to the first video, 20 on 56. Very good. So, I tend to leave my fractions unfactorized, so just leave them in their large form, just because when we add and subtract fractions, it's easier if they all have the same denominator. And we're going to see this here in part C. Now, there are two ways we can solve for part C. One is algebraically, the other is using this tree diagram. So I'll step you through both of those now. The way we can use the tree diagram to solve for one green and one red, we multiply for these two branches because they happen after each other. So this branch happens first, and then so that probability is 3 on 8. And then what we need to find is the probability that green will happen after this other green. So that is, it's the probability of the first green multiplied by the probability of the second, because it's a two-step problem. So a two-step problem means we need to figure out the probability of this first step, which we have, and multiply that by the probability of the second step. Now, once we've solved for these two greens, so green and red, and red and green, which satisfies our equation of one green and one red, what we do is we multiply 5 on 8 by 3 on 7, and 3 on 8 by 5 on 7, and then we add this probability and this probability. We add the two together to find the overall probability. So what that is going to look like is 5 on 8 times 3 on 7. So that is the probability of this branch here plus 3 on 8 times 5 on 7. So why is this? This is because we're multiplying the probability of that first green branch times the probability of this red branch to find the probability of this overall branch. So what we get is 15 on 56 plus 15 on 56, which is 30 on 56. But if you haven't drawn a Venn diagram, or you want to do this in another way, there is a formula you can use. The formula is going to be probability of A is equal to 1 minus the probability of not A, or the complement of A. Now, what does this mean? So if the probability of A is red, green, then the probability of not A is going to be green, green, or red, red. So the reason this is the case is because red, green, the opposite of that, so the complement of it, so that is opposite of probability of A, is going to be everything apart from one red and one green. So that's going to be one green and one green, and one red and one red. So if we draw out this equation now and we place the values into it, probability of A, which we've defined as red and one green, is 1 minus the probability of green, which you calculated, of two greens, which we calculated to be 6 on 56, minus the probability of two reds, which we calculated to be 20 on 56. There we go. So probability of A then, if we solve, is 56 on 56, 56 minus 20 on 56. So now you see how having all the same denominators helped us just solve this equation faster, because we don't need to multiply any of these back to get them on the same denominator. 30 on 56. So exact same value as we got the other way. So both ways are very valid. One is algebraic, of course, while the other uses the Venn diagram. I hope this has helped. Don't forget to go into the Answer Me website to vote for next week's topic, and stick around for the next video, the third video, where we're going to look at expected probability. See you then.